Okay, so this talk has been in the works for around a month. This talk, I changed my choice of topics just before I was going out to Bryce Canyon for the Astronomical League convention at the end of June. There were fires burning 3 miles away from the hotel where we were staying. So I decided that I would talk about forest fires and astronomy, because for the last 3 summers here, we've had a lot of smoke from fires. The first year was Canada, Western Canada. Then 2 summers ago, there were fires in Quebec. Last year, there were fires in Los Angeles. This year, the fires seem to be hitting Canada, California, Arizona, Utah. I think Quebec is okay though. Yes. Yep. Yeah. Frank Miller just pointed out New Jersey. Okay, so I'll be talking about what a wildfire is, which most of us know, how they affect astronomy. It's not just the smoke that we experience here. There are other ways they affect astronomy. Then how tools from astronomy are used to help fight fires, how to predict when your view will be affected by smoke, and then more about what I experienced when I was out in Arizona and Utah 4 weeks ago. Okay, so I'll start by defining what a wildfire is. It's an uncontrolled fire, meaning that if there's sometimes there are intentional burns done to protect against future wildfires. A planned burn isn't a wildfire. And in an area of combustible vegetation. So it can include when the Pine Barrens on Long Island catches fire, which seems to happen around once every 10 years. There's a bad fire in the Pine Barrens. It can happen places other than forests, though, including peat bogs. And there's, I didn't research this, but I vaguely recall hearing about something. This was a few years ago. There's like this giant mushroom colony in Kentucky that's all underground, and that's been slowly burning for like years. There's like there's an underground fire that's sort of considered a wildfire also. Oh, yeah, but that's coal burning. It's not a wildfire. It's an uncontrolled fire, but it doesn't meet the criteria of being traditional wildfire yet. So to form a fire, you need a combination of oxygen, which is everywhere on Earth. You need fuel, which trees, grasses, when they're dry, make good fuel. And then you need enough heat to get the fire started. Common causes of wildfires, it's mostly from humans. Either someone lights a campfire and doesn't put it out correctly, someone's burning leaves in their backyard because they don't want to bag them, and that gets out of control. Cigarettes thrown out of car windows. Less common, car driving along in an area of tall, dry grass. Car gets a flat tire, pulls off the road. The hot bottom of the car can ignite a grass fire. Lawnmowers have occasionally caused wildfires. And then lightning strikes are another way that they start. And an interesting thing about lightning strikes It's not lightning hits, the tree bursts into flames. Sometimes the tree will smolder inside. The tree doesn't really look like it's on fire, but it's burning from the inside out. And when it reaches the outside, then there's oxygen to feed it, and it actually bursts into flame. So just because a lightning storm came through the forest today and no one sees a fire, there's a risk of fire showing up for the next week or so. And then once the fire starts, a lot of fires start, and if it's an unintentional fire, if there's somebody there to see it, well, they call 911 and it gets put out before it spreads. If it's in the wilderness and either no one around, or if it was caused by a human either accidentally or arson, well, that person's not going to call 911. If you're either trying to cause the fire, or if you've accidentally started the fire, you might panic and say, "Oh, I'm not going to call 911." And then if it's warm enough, dry enough, and especially wind, the fire will spread and become uncontrollable. And then a lot of other natural features, mountains, water, and unnatural features, roads. Roads can prevent a fire from spreading across them. And then this diagram shows what's called the multi-scale fire triangle. The inner layer is that heat, oxygen, and fuel. That covers like short-term things. Then there's the middle ring in orange and the outer ring in yellow. That outer ring in yellow are very, very long-term conditions. That it's not just today's weather, it's the climate. What has the weather been for the last 3 seasons? And one thing that will frequently trigger fires, if there's an unusual amount of rain that causes everything to grow, followed by a drought, because then you have a lot of fuel. So it's rain followed by dry conditions. If you've had a drought for 3 years, well, the stuff that's out there is dry, but new things haven't been growing. So you're unlikely to get a fire. And past fires will decrease future fires. And yeah, if anyone has any questions, feel free to. Yes, Frank.
The 85% of wildfires in the United States are caused by humans?
Yes. Yeah, yep.
Wildfires caused by humans?
No, though, well, some are, and this is it. This is in the USA, but a lot of fires in the US, there for these reasons, either a campfire that got out of control, or someone threw a cigarette out of their car window that sparked the fire. So it's not. It's 85% of all human-caused fires. That includes arson as well as the accidental ones. But yeah, that's based on an analysis of fires from the year 2000 to 2017. But I don't think it's changed. I mean, people are still people. And the last Pine Barrens fire, it wasn't a very, very large fire, but it was very poorly reported. At first, it was reported that someone had a fire in their backyard that got out of control, but it turned out that that story was completely false. The fire had some other cause, but so somebody got scapegoated and was very unpopular and until that correction was made. So these fires, how do they affect? Well, I'll start off by talking about professional astronomy, because we know that the smoke affects us every summer. So observatories, when there's a local fire, buildings, telescopes, and other equipment can be damaged if the fire spreads to the observatory, or even if the smoke is nearby, that can collect on optical equipment, which is not good. But even if the fire isn't, that doesn't cause any physical damage, if they're these remote observatories that only have one mountain road getting up, if the fire is anywhere near that road, they evacuate all of the workers because you don't want people stranded there. So sometimes professional observatories, which I'll name some, have had to shut down for a week or more because the fire was threatening. And then more distant fires that aren't a direct safety threat, smoke affects our viewing in two ways. One is the smoke makes the sky less transparent, so the starlight doesn't reach us as well. The other factor, if there's any light pollution, the light pollution is bouncing off the bottom of the smoke, so it's amplifying the light pollution. Yeah, so some observatories within the last 5 years that have had issues. Kitt Peak in Arizona, a few of their support buildings caught fire. It didn't affect any of their telescopes, but it seriously hampered their operations. Mount Wilson has had nearby fires. Mount Wilson is up in the very wooded hills outside of Los Angeles, and it's had several threats in 2020 and 25. And there was a smaller observatory near Los Angeles that's done a lot of variable star observing that burnt in 2024. And this image shows a webcam from Kitt Peak, and you can see how close those fires were to the top of the mountain. So this space science, satellites, space telescopes look out into the sky. Space telescopes also look down at Earth to monitor fires. This image shows heat at Earth's surface, and you don't see it at this scale, but individual pixels can pick up small local fires before anyone's aware of it. So satellites can be used to detect fires. They can be used during the actual fire to plan how to fight the fire. Because often, if there's enough smoke, simple aerial photos can't see what's burning. So by mapping out exactly what's currently burning, they can predict where the fire is going to go next in order to better direct resources. These wildfires, it's not like on Long Island when there's a fire. We have roads everywhere, and we have fire departments everywhere. It's pretty easy to fight a fire in the Pine Barrens. If you're out in the wilderness, well, they often have to construct roads just to get to the dirt roads, but they've got to clear a path through the trees to get a fire truck in there. And then weather forecasting also, if there are two fires in an area, both burning, and there are only enough resources to properly fight one of them, well, if one's going to get rain tomorrow, don't fight that fire. Fight the one that's going to have a drought for the next 2 weeks. Yes, Matt?
John, how many of the larger observatories have fire breaks in and around their buildings? I mean, the actual observatory.
Okay, Matt's question was how many professional observatories have fire breaks? My guess is they're starting to do that now, but if you look at this picture of Kitt Peak,
Yeah.
they've got trees all around their telescopes. Kitt Peak, it's at altitude, but it's not so high that it's above the tree line. Like a place like Mauna Kea or the observatories down in Chile, they're pretty safe from fires because they don't even have enough oxygen to feed a fire well. So I'm sure that they have fire plans in place, but there's no fire break. They haven't. They may want to consider clear cutting that mountain now, but yeah, I don't know what specific fire plans the observatories have.
There were two fires on Mount Wilson. One was a couple of years ago, and I think one was 15 years ago. And they nearly lost Mount Wilson. But they were able to, the fire department was there, but then some houses were threatened. So firemen left and they said, we promise we'll be back. And they came back and they did manage to save it. My guess is they've done some serious, clearing of brush and stuff around the mountain, knowing what can happen. And then a year and a half ago, they had another fire coming up and it was not as severe and they were able to keep it away from the telescope. In 2003, there's an observatory in Australia called Mount Stromlo. It had 5 telescopes on it, including the Great Melbourne Telescope, which was beginning of the century, I think, and all 5 were absolutely destroyed. And they're big, heavy, some of them are big, heavy things, and they found mirrors, which were just globs of glass with pieces of metal melted into them. And the observers, the head observer, his house burned down and workshops burned down, and it's come back. They built some new instruments, but that has to be one of the worst ever to lose 5 professional telescopes.
Yeah, that was at the time the biggest professional observatory in Australia. So some specific satellites that are used, it's the geostationary operational environmental satellites. There have been a total of 19 satellites going back to 1975, obviously upgraded models as time progressed. There are only 2 operational today. There's GOES East, which is sort of parked over the equator, over the Atlantic Ocean, and GOES West is over the Pacific Ocean. And their overlapping fields of view cover the entire United States. They're able to detect, they're built primarily for weather forecasting. They were built and launched by NASA. They're operated by NOAA. And by analyzing what's going on at the ground, they look at optical wavelengths, infrared, and other wavelengths. They're able to determine where fires are, often long before anybody would have spotted the fire. And even if the fire is so small that it doesn't fully light up a pixel for the astrophotographers here, the way that auto guiding can look at a star and, oh, this pixel is trying to take it brighter, so it means the star is drifting. Well, sort of the same thing can be used, the same idea that, oh, this pixel, this collection of pixels is all the same shade of gray. This one is now a little bit brighter than the surrounding ones. Now this one's a little bit brighter. It's not a full fire, but it's this little tiny fire that can be used to predict where fires are. And the cool thing about these GOES satellites, NASA has a website where they're updating several times an hour. All of this data is there. All 16 wavelengths of light that they're collecting is downloadable. And some more analytical products, because by looking at the raw data, these 16 raw images, it's like, okay, what am I looking at here? They'll also combine them in various ways. Like this image down here on the left, that's combining multiple images to say, okay, this is likely to be a fire. This might be a fire. This is not a fire. And there's something new that I just learned about. July 23rd, last week, it's a combination of, there's something called the Earth Fire Alliance. It's a nonprofit wildfire fighting group. They're working with a private space company, Muon Space, that built a satellite. And Google is doing AI processing of this. And they found, for example, a small fire on the side of the road in Oregon, and were able to fight that fire that otherwise wouldn't have been detected until it grew more. It was too small for the GOES satellite to pick up yet. And their plan is to build a network by 2030 of 50 satellites that will be able to check every spot on Earth every 20 minutes. So it's pretty, and there's talk about using this like to find like house fires. If a house fire shows up, Google's AI will call the local fire department before the people who live in the house do it. Yeah, so there's very little information about this. I know it was a press release, and it was their prototype satellite was launched in April. They had their press release with first sample photos last week. Next year, they plan to launch 3 operational satellites that'll check every spot on Earth every 12 hours. So it's good, but not as good as it's rather ambitious for their 50 satellite network. I don't know. I've never heard of the Earth Fire Alliance before. I'm not sure where they're getting their funding. Oh, yep.
No, I don't know. Is there any information on the resolution and field of view of the sensors that they're using? I mean, the Earth in 20 minutes, that's pretty big field of view, and
Yeah.
it's pretty hard to see how you could get the adequate resolution to localize it.
They're showing some scale on the
I
right.
Yeah.
see it, 1
I,
kilometer.
yeah, but
That's a,
you're not gonna
Yeah.
image
Small
the
file.
Earth in 20
No,
minutes
yeah.
at a
No,
1 kilometer.
No, but
even
with
with 50 satellites.
50 plus.
Yeah.
yeah, no, with yeah,
It's a big one.
yeah. If you had if you have, every, every area of Earth, if a satellite's passing, I'm, I'm not sure how wide of a path they scan on each orbit, like the GOES satellites, they,
Well, they're geosynchronous,
Yes,
so they're not
right,
standing in.
yes, yeah, yeah, the GOES satellites, they're geostationary, so they see half of the Earth at any given time. I don't know what orbit this, but my guess is they're in near polar orbits, because that's the most efficient if you're trying to pass over every place on Earth. Yeah, there. Yeah, again, I just learned about this a week ago while I was doing other research. Okay, now, what does this mean for us and our hobby of looking at the sky, photographing the sky? Well, it's important for local fires, especially on Long Island, don't affect us that much. But those forest fires out west that create a lot of smoke, they definitely affect us for days and weeks sometimes. So my experience when I was out at Bryce Canyon, because the fire was burning so close, the wind direction, like small shifts in the wind every evening, it seems like the predominant weather patterns in Utah is during the day, wind blows out of the southwest, and then it shifts to a more to blow more from the north. So smoke plumes during the day are going sort of north, and at night they're going sort of south. So by looking at that, the early evenings, if you're north of the fire, you get smoke. If you're south, it's good. In the very early morning, north of the fire, you likely don't have smoke because if you're only a few miles away from the fire, that smoke plume hasn't had a chance to expand. Like if in New York, if there's a fire in California that's affecting our air conditions, if the wind shifts a little bit, it doesn't affect it. It doesn't redirect that smoke plume much. It takes several days of weather patterns to change that. But the closer you are to the fire, the more shiftable the smoke plume is. And this, for very local fires, this is an anecdote that doesn't affect the surrounding. Campfires sort of feels like if you're standing near a campfire, the smoke's blowing in your direction. So you're like, oh, I'll go stand over here, and the smoke heads towards you. Well, that's because you standing near the fire changes the local wind patterns to direct the smoke towards you, because fires pull cool air in from the ground and they rise. Well, you're blocking the cool air from going into the fire. So if it feels like wherever you stand around a campfire, smoke is going in your direction, that's because if other people are standing around the fire, it's less of a factor. But if you're the only one standing around a campfire, smoke will head towards you. So as far as predicting smoke when we're observing, I really like weather.gov, fire.airnow.gov, and I think we're all aware of Astrospheric, which is a weather forecast customized for astronomy. That is another way of predicting which nights will be affected by smoke. So this is just a screenshot of fire.airnow.gov. And this is designed, it's designed mostly for health reasons. So it's these colored dots on the ground, that's showing air quality at ground level. But the data also includes, and the smoke plumes are shown, and every fire detected on the ground is shown. The fires are of varying sizes. You can click on individual fires to see how big they are. So this site provides a lot of detailed information, including if for the larger fires, if you click on it, there's a link that will take you to another page that has a log of all the firefighting activities. And the bigger fires out west can have 500, 1,000 firefighters on the ground fighting the fire.
John, is this fire.mo.gov?
Fire.airnow.gov, yes. Because this I found very, very helpful while I was out in Bryce Canyon to get that running log of exactly what was going on. Okay, so now my personal experience with the Southwest fires. I visited 3 national parks. All 3 of them had 1 or more fires burning pretty close to the park. We flew in to Las Vegas Airport and rented our car there. Neither my wife nor I are gamblers, so we landed in Vegas and immediately headed out of Vegas. So we passed through Zion Canyon that had a fire burning around 10 miles away, creating a lot of smoke. The Grand Canyon, while we were there were no fires. Skies at the Grand Canyon were perfect. Unfortunately, fortunately for us, unfortunate for the future, after we left, 2 fires popped up near the Grand Canyon, one sort of south of the south edge, sorry, what was it? Yeah, the south edge of the North Rim. So very, very close to where like the national park at the North Rim is. The other that was what was called the Dragon Bravo fire. The White Sage fire was burning maybe 20, 30 miles away from the Grand Canyon Lodge. The South fire was believed to be under control. They had fire breaks around it. It wasn't spreading. The North fire wasn't a direct threat to the lodge, but it was very close to the only highway to get to the Grand Canyon. So the National Park Service decided to close down the north rim of the Grand Canyon ahead of time, evacuated most non-essential staff and of course all visitors. But then there was an unexpected day of 50-mile-an-hour wind gusts that caused the smaller Dragon Bravo fire to leap across containment barrier, reach a water treatment plant that was still pretty far from the lodge. It reached a chlorine tank. The chlorine tank overheated, burst, toxic gas, so the firefighters had to evacuate. And then the like 80 buildings at the north rim of the Grand Canyon are gone. The lodge is gone, the visitor center is gone, a lot of cabins are gone. Yeah, the entire north rim of the Grand Canyon is essentially burnt. And I don't have a photo of this, but the aerial photos, the cabin that I was staying in burnt. The trees around the cabin look untouched. Pretty much all what happened was it was like all the pine needles and stuff at the ground caught fire. The trees were fire resistant enough. The tall mature trees didn't burn. And you might also know, like, tall pine trees don't have branches down low near the ground. Maybe that's because of fires. I don't know why, or is it because they get more light up high and having leaves down low that are in shade all the time isn't, I'm not a tree expert. But yeah, the Grand Canyon, the north rim of the Grand Canyon was devastated. Most visitors to the Grand Canyon end up going to the south rim because it's much more developed. There are roads there are 3 separate highways to get in. The north rim, from the north rim, the nearest grocery store is like an hour-and-a-half drive, I think, because you have to drive out on this access road, and then you have to drive another 30 miles or so to get to the nearest town, which is a tiny town. There. And it takes around 4.5 hours from Vegas to reach the north rim of the Grand Canyon. The south rim, I think is closer to like 3 hours. So almost everyone who's going to the Grand Canyon goes to the south rim. That's why what was so disheartening about this, the north rim I enjoyed so much more than the south rim. The north rim is remote, not many people. But yeah, it happens. The lodge that was there wasn't the original. The original lodge that was built on the site burnt due to a kitchen fire around 100 years ago, got rebuilt. And then at Bryce Canyon, we spent 4 nights at Bryce Canyon. The France Canyon fire was right before we left New York. I was checking the weather forecast, checking the fire forecast every single day. Just like, okay, this is really close. Do I want to risk being at the hotel when it burns down? And it was a concern. Some people canceled their trips because of either concerns about the fire or about the air quality. Fortunately, my wife, who has asthma, the smoke doesn't seem to bother her. But yeah, that France Canyon fire now is completely under control. This was the view from the the skies were pristine when we were there. There was no smoke anywhere on the horizon. Like the first 5 degrees above the horizon was schmutzy from smoke because they're having such a drought. Atmospheric transparency is great, but fires off in the distance were a problem. But the fire that burnt this down, and it's mostly stone, but there's enough wood to to burn, and the cabins were all wood. Yeah, and this is not a layered image. That's the Milky Way, despite the relatively bright lights from that lodge. The skies there are very dark.
Second,
This is it's either a 20 or 30-second photo. Yeah, it's a single exposure. Probably ISO. It's either 3200 or 6400. Yeah, I'd have to. Yeah, this is either at 3200 or 6400. Probably 20 seconds and a 15 mm focal length.
John, is
Yeah.
that a composite or?
No, it's a single image.
How did you manage to not wash out one or the other?
Because the lodge is not, it looks really brightly lit here, but it's a dark sky park, so the lighting is relatively subdued. It's not lit like a typical hotel is lit up at night. So that's how I was able to take there wasn't that much glare. And the original photo straight out of the camera, the building looked a bit blown out. I dimmed the highlights in this photo. But yeah, that building is gone. The cabin I stayed at is gone. The visitor center is gone. And this is going to have impact until things get rebuilt. The inner canyon, the bottom of the canyon, the water supply, I believe, was fed from the north rim. Well, if they can't provide fresh water there, people who are hiking from the south rim to the base of the canyon and back can't refill their water from a filtered, they either have to carry all of their water with them, or you have to refill from the river and either boil or treat it with tablets or filters. But yeah, in the grand scheme of things, it's not a major disaster, but it does impact people's enjoyment of the Grand Canyon. And those fires are still burning, depending on the wind direction and such. Forest fires, the smoke, especially in the evening, as the weather cools, the smoke settles at the lowest point. So the Grand Canyon is filling with smoke. Some days they said no one's allowed to hike down here because the air quality, it's not just 110 degrees, it's 110-degree smoky air. Yeah, there's a very rustic cabin called Phantom Lodge at the base of the Grand Canyon. You've got to plan and make reservations like years in advance because it's so in demand. But that's affected by these fires. So then this fire, this was the fire near Bryce Canyon. You can see how how much smoke that's generating. But again, depending on how the wind was, like from this vantage point, straight overhead, skies were pristine because all of that smoke was drifting with the wind. This was Bryce Canyon.
Oh, man.
Yeah, each morning, and Bryce Canyon, it's called a canyon. Technically, it's not a canyon. It wasn't formed by like a river cutting through it. These rocks have these rock formations have eroded over the years from, I think the winter weather is the biggest factor. Water gets into the rocks, cracks, splits them apart. And then over millions of years, also the wind, as it blows through the area, erodes different layers of rock at different levels. But the smoke was collecting in the low points. It looks almost like fog in the distance, but the smoke, every morning the smoke would pour in, which for astronomy was okay because at night the skies were clear.
John, that's an astounding photograph, having seen it when it was
Thanks, yeah.
clear. Wow, that's just unimaginable.
Yeah, this was a view. This was outside, just like 5 miles away from Bryce Canyon itself. And you can see in the lower right, that glow, those are the fires. But the smoke, yeah, the smoke was staying low. So the only downside of the smoke on observing was I was hoping to see Omega Centauri. Because from Long Island, and for those who haven't heard of it before, Omega Centauri is a globular star cluster, or for Dave Bush, a globular star cluster.
I was waiting for that.
And I think Dave is more correct. Unfortunately, English is not at all based on logic and math. So Omega Centauri, it's a globular star cluster that's only visible, barely visible if you get really, really lucky. There's a point every spring where it gets around a ½ degree above the ocean. So on Long Island, oh, 2 degrees, okay. Yeah. As far as I know, no one on Long Island's ever seen it. With
Carl see it?
well,
Yeah, Steve and I saw it.
right through
Plan we saw,
through.
although,
Wait, you
Tom Panino's always
you-
questioned us.
Oh, I've seen it plenty of times.
you saw it through a scope, not naked eye, right?
All right, not naked eye.
Okay.
I'll buy it.
But for further south, it's a naked eye object because it's around the size of the moon. It's much dimmer than the moon is. But if you're in dark skies, you look around for it. It's like I can't see that, and then it pops out once you see it. Being further south in Arizona, I was hoping to see it, but it was lost in that smoke.
You could see in Florida.
John,
Oh, yeah.
can you-
Oh yeah, right. Yes, yeah.
They even talk about, you know, in Titusville, we go to Spike and see it. I'm gonna do
Right.
that.
Oh yeah, yeah. I've
Not much time though.
yeah, I have seen it before from New Mexico.
I saw it Florida Keys. Goes up and down.
Oh, you went past it.
This is a photo of one of the few sources of water near Bryce Canyon. Is this tiny, tiny stream and waterfall. And because this night it was a little smoky, I tried to take a star trail instead of a single exposure, smoke or clouds blowing through in a 5-minute exposure aren't, they sort of just blur out. This is another view of Bryce Canyon. And just as an example of how dark the skies were, if you look at the center bottom of the photo, you'll see the rocks in that distance, they look like they're lit up. That's because it was 2 days, 2 days, yeah, 2 days past new moon. So there was some moonlight. There was some moonlight just hitting those rocks. The rocks where I was were in shadow because there were taller rocks behind me. But just the crescent moon, without any light pollution, the crescent moon lights up the landscape. Yeah, what was nice about being at Bryce Canyon for 4 consecutive nights, I really had a chance to learn the place. Like this evening, I hiked down during twilight, so I at least had some natural light to see by. Sat there for 2 hours waiting for it to get dark. Took my photos, and then I had to hike back in utter darkness.
Trail that is like really zigzaggy?
No, this trail. Okay. Oh, this of this year, March of this year. Okay. Yes, yeah. Yeah, they get rough winters there. That zigzaggy trail is what's called the Navajo Trail. That's a little bit further south in the park than this is. This was in between what's called Sunrise and Sunset Points. Yeah. This, depending on which way you go through the loop. If you hike down from Sunrise and Sunset Point, go. Yeah, so if you hike clockwise, in a clockwise direction, you would go down here first and then come back up through the zigzag trail. Okay. Okay, so this is my presentation.